Hello everybody and welcome to another math class with Mr. Eichler. Today we are ever increasing our depth in the world of fractions, and today we are going to take a look at addition of fractions. Now keep in mind, this is not your mother and father's addition of fractions. This is with decomposition, and yes, you got to be able to do it this way, Mom and Dad, please. I understand that you will want to show them your way that you grew up with. However, they've got to be able to do it this way for our year-to-end tests, because they will have to write explanations and they're going to have to explain this decomposition process. It's good that they know it the traditional way. They'll be able to look at it. They can check their work this way. They can do it two different ways and make sure that both answers are correct. Hey, we're guaranteed we're going to get a right answer. But they've got to be able to decompose. Okay. Enough said about that. I'm going to go over here. Hey, there I am. And we're going to take a look at this thing known as addition of fractions with decomposition. Now, with any addition and subtraction, you have two basic rules to follow by here. Okay, rule number one, and most importantly, you must have common denominators. If you don't have common denominators, you cannot add. You are adding oranges and apples. Screen. Oranges and apples. And if you don't have 6 fruit, you have 3 oranges, you have 3 apples, you have 3 oranges and 3 apples. You must have common denominators. That is not a 4th grade standard, in case you're curious. We're not going to be adding and subtracting, finding common denominators and moving on from there. That's next year. That's 5th grade. What we will be doing is what follows. Second rule, you never add or subtract the denominators. This is an important rule. When you get a common denominator, you write that common denominator down underneath your answer and you leave it alone. You don't touch the denominators after they're the same. Boom, just leave them what they are, move it over to the answer, done'sers. Okay, let's go with our first example here. Switching over to my wonderful pen tool. Okay, we have 3/7 plus 2/7. Now I know what you're thinking, 5. I know, because 5, right? However, this is a good way to look at it and make sure that it's right. But what we need to be able to do is decompose. By decomposing, again, we take a whole fraction and we smash it into pieces. How many pieces? However many our numerator tells us. So I have 1, 2, 3 sevenths. And yeah, forgive me, I'm writing with the mouse here. It might be a slight messy. And then over here, I have 2 sevenths. 1, 2 sevenths, sevenths. Okay, so now what do I do? Well, now I add them together. 1, 2, 3, 4, 5. 5 sevenths. And I know what you're thinking, Mom and Dad, but we could have just added them. Yes, we could have. And at this stage, it's pretty simple. However, at this stage, this actually will save us the next step, which is converting it from an improper fraction to a proper fraction, or to a mixed number, excuse me. So again, let's begin by decomposing. I have 4 sevenths plus 6 sevenths. So 1, 2, 3, 4 sevenths, 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 plus 1, 2, 3, 4, 5, 6 sevenths. Mouse writing for fun and profit. Okay, sorry if those are running uphill there. Now what do? Now I need to count them up, and I get 10. Oh, but wait, there's a better way to do this. I take a look at my denominator, and I ask myself, how many are in the whole number? That's the W-H-O-L-E number, not the H-O-L-E number. How many in the whole number? Well, 7 sevenths will equal 1 whole. Remember, same number as numerator, same number as denominator, equals 1 whole. Okay? So I look at my I look at my denominator. I wrote the denominator, and then I write the denominator as my numerator, and this reminds me what my whole number is. Why did I just do all of this? Because this. 1, 2, 3, 4, 5, 6, 7. And I make a big box because that equals 1 whole plus 1, 2, 3 sevenths. My answer is 1 and 3 sevenths because these 3 sevenths will recompose to become 3 sevenths. Okay? Our next example. Mixed fractions. It's not that bad. It's really not that bad, I promise. You're going to be okay. Let's go for a different color, shall we? We always begin with decomposition. We always break down our fractions. Okay? So I've got 2 wholes this time. So that means I just need to make a 3/3 because 3/3 equals 2 wholes, right? No, it doesn't. 3/3 equals 1 whole because 1 equals numerator and denominator the same. With this equation, I'm working in thirds, but I have 2 wholes, and this equals 1 whole, which means I need 2 1 wholes. Then I take my 2/3 and make it 1/3 and 1/3 plus 1 whole. I just need 1 whole and 2 more thirds. 1, 2, 3rd, 3rd. Now we add them up. So how many in my whole? 3 wholes. 3/3 in a whole, excuse me. 3/3 in a whole. So 1, 2, and 3. So now we get fun with creative drawing. And we do that because it's the only place you're ever going to get away with a ginormous squiggly line. Yay for math. So that's 1. And I still have 1/3 over here remaining. This 3/3, that's a 1. This 3/3, that's a 1. This 3/3, that's a 1. 1, 2, 3, 4 thirds. No. 1, 2, 3, 4 wholes. So we have 4 wholes and 1/3 remaining. By using decomposition and recomposition of the fractions, we eliminate the need to, we eliminate the step by ending up with a improper fraction and then having to convert that into the mixed number. Okay, this helps to give us the simplest answer. It won't necessarily give us simplest form. Another note for 4th grade curriculum, we do not need to reduce to simplest form. Okay, that is also a 5th grade standard. That is that. We will continue this in our next lecture when we talk about simple subtraction by decomposition. Thank you all for tuning in. We'll see you soon.